So today we're going to continue our logic and we're going to discuss biconditional statements and some definitions. If you'll notice, there's a few Venn diagrams here also for you. So let's review quickly the conditional and the converse. When we talked about the conditional, we know that we were saying if A, then B. So the if statement is our hypothesis and the then statement is our conclusion. And this is noted by our Venn diagram. So A is a part of B. If we review the converse, we then remember that the converse changes the order. So now we are stating if B, then A. So again, illustrated by our Venn diagram, we have B within A. And today we're going to move to the biconditional. So bi prefix meaning to, and we have the statement A if and only if B. So we'll see now how these two will come together. When you combine a conditional statement and its converse, you create a biconditional statement. P if and only if Q. So now we're looking at the conditional and its converse, and we have new notation. P if and only if Q. And you'll notice the double arrows now to illustrate we're talking about the if and only if. So what's happening with this new notation, the if and only if statement, we mean that if P then Q and if Q then P. And together we get that if and only if biconditional statement. So let's take a look at your handout and do a few examples. For these first two, we're going to write the conditional statement and converse within each biconditional. The tea kettle is whistling if and only if the water is boiling. So let's take a look at identifying the conditional statement first. So if we split up this statement, we know that the tea kettle is whistling. So our conditional, if the tea kettle is whistling, then the water is boiling. If we were to write our converse, then we're going to just change the order. So now we will look at if the water is boiling, then the tea kettle is whistling. So again, all we've done thus far is taken our conditional, change the order, and then we get the converse statement. For number two, a biconditional is true if and only if the conditional and converse are both true. So for the conditional, we're going to write the if-then statement. So, if a biconditional is true, then the conditional and converse are both true. From here, if we take the converse, we will just switch the order. So, if the conditional and converse are both true, then the biconditional is true. So again, so far just working from the biconditional statements and splitting up each conditional and converse. Let's take a look at a few more. In this section, for each conditional, write the converse and a biconditional statement. So for the conditional, if n is an odd number, then n minus 1 is divisible by 2. So take a moment, pause the video, and you try the converse. For your converse statement, you should have if n minus 1 is divisible by 2, then n is an odd number. How'd you do? What about the biconditional? Pause, and then check your answer. For the biconditional, you should have n is an odd number if and only if n minus 1 is divisible by 2. So now we're taking our conditional and our converse and creating that biconditional statement. Number 4, an angle is obtuse when it measures between 90 and 180 degrees. So now let's write the converse. Pause the video and try it on your own. you should have for our converse statement. If an angle measures between 90 and 180 degrees, then the angle is obtuse. Now try the biconditional. For your biconditional statement, did you have an angle is obtuse if and only if it measures between 90 and 180 degrees? So this is a little introduction on your biconditional statements, again working with our previous conditionals and other conditional statements from earlier in the chapter. For your homework assignment due next class, go ahead and finish the rest of this handout and do numbers 5 through 8 for next time.